quickcode.com. It starts with a K, K-U-I-C-K, C-O-D.com. The problem is minimum height tree. So given a graph n equals to 4, meaning 4 nodes starting from 0, 0, 1, 2, 3, so total 4 nodes and edges. So here 1 has a neighbor which is 0, so 1 has a neighbor which is 0, 1 has a neighbor which is 2, so 1 has a neighbor which is 2, and 1 has a neighbor which is 3, 1 has a neighbor which is 3. So this is a tree. So if 0 is the root, then it looks like that, and if 1 is a root, the tree look like this. If 2 is a root, then tree look like this. If 3 is a root, then it looks like this. Then out of all these trees, which tree has the minimum height? So this tree has the minimum height. So take this root, put it into a list and return it, and that will be the answer that is required. Let's take another example. So this is, if we create graph with this input, and then we can have multiple graph with multiple heights. So for example, if we think 0 as a root, then 0 will come here, then the height will be 1, 2, 3, which is not minimum, right? When 3 is root, then the height is minimum 1 and 2. Similarly, when 4 is root, height is minimum, which is 1 and 2, so height is 2. Therefore, we'll create a list, add these two node values to the list and return it as an answer. I said 3 and 4 is the answer, 3 and 4 is the answer, and here 1 is the answer. So this is the problem, and we have to solve this problem. So I explained the key insights that I'm going over again. So basically the approach would be here. Look at here in this graph, right? If this graph has 4 nodes, you see, if there are more nodes here, this side, this side, this side, and this side, then what would be, which node should be treated as root so that the height will be less? Basically that answer will come somewhere from the middle, because if we treat one of the leaf node as root, then obviously it will not make a minimum height tree. So to make a minimum height, the node must be somewhere in the middle. For example, like this, 1 is in the middle. So when 1 is treated as root, then the height of the tree becomes minimum. So now if you can visualize that this is a very complex graph, right? So this has many nodes, 2 has many other nodes, 1 has 0 has many other nodes. So what we will do, we'll just prune all the leaf nodes, right? All the leaf nodes. Then the new graph will have a new set of leaf nodes. Then again we'll prune all the leaf nodes, right? And we'll do the process until the graph has 2 or 1 element, 1 nodes left, because the answer will always be either 1 node or 2 node, right? Because you can have like a if you think of a 2 node graph, like node 1 and node 2. So if you think this one as a root, then length will be 1, and if you think this one as a root, the length will be 1 as well, right? So if the graph has 2 nodes or 1 node, so any node viewed as root will have same length, right? So with that in mind, let's see how this is solved. So we come here. So basically this is the total node, right, and this is the edges. So if the total node is less than or equal to 2, then we'll just create the answer list and return it, right? Very simple. And then now we create a graph with adjacency list, right? So this is a list of hash set. So I'm just looping through the nodes and then adding I'm instantiating the hash set to the list, and then in another loop through the edges I'm creating the adjacency list. So if one node has a neighbor of, say, node 1 and node 2, so node 1 has a neighbor which is node 2, so node 1 must have a neighbor list, and that should contain neighbor 2, right? And similarly node 2 has a neighbor which is node 1, So node 2 neighbor list should contain neighbor 1 and node 1 as neighbor, right? So that's why you have these two entries. So now what we'll do, we'll find the leaf nodes. So how can I find the leaf nodes? We'll iterate through the adjacency list and find which node has a neighbor, only one neighbor. So if a node has a one neighbor, that means that is a leaf node. Let's see here. Say this is a leaf node. Why? Because it has only one neighbor, and 1 is not a leaf node because it has 3 neighbor, more than one neighbor. So and then we find the leaf nodes and then we add it to the leaf list. So now this leaves has all the leaf nodes. So next what we'll do, we'll prune them from the graph, right? And then the graph will have new set of leaf nodes. We'll add them to the new leaf nodes, and then we assign the new leaf nodes to the leaf nodes and repeat the process, right? So now what I'm going to do, now I'm going to remove this many leaf nodes, right? Leaf dot size. So just deduct this number from this n and then create a new leaf nodes, because as we remove, we also populate the new leaf nodes to this leaf nodes, right? So I'm looping through the leaf nodes. So I found a leaf node, right? So now I'll remove it from the graph. So this leaf node has a neighbor, and that neighbor also has a neighbor list, and that neighbor list has this node as neighbor, right? So we have to remove that reference from the neighbor. So we're going to remove the neighbor, the reference of leaf node from the neighbor. So how can I remove it? So we have the adjacency list and we got the leaf node, right? So leaf node always has one neighbor. So iterator next will provide the one neighbor only, right? So this neighbor has the reference of, and this neighbor has the neighbor, right, which is this current leaf node. So we're going to remove that. So we pull this neighbor from the adjacency list. Now this will return a set of neighbors, right? From this neighbor we'll remove myself, which is myself meaning the current leaf. So current leaf is removed from my neighbor, right? And then after removing, if this has only one neighbor, current leaf has one neighbor, then current leaf become a new leaf, right? So sorry, I think if the neighbor's neighbor has only one neighbor, right, then it becomes a leaf. So if it becomes leaf, then we add it to the new leaves, okay? And then after adding, because these leaves will be deleted in the next step, so after picking up all the new leaves, we just assign the new leaves to the leaves so that the process continues until the graph has only 1 or 2 nodes. So finally we'll remove this leaves list, which will be our answer. So if you want to practice, then you can write your code in here, right? So I already wrote this code. Let me reset it. So you can write your code in here. So let me copy paste, copy and paste it here. So and then on this input I'm going to run this. Okay, so let me see. So here, quick, it's executed, right? And then if I submit, there are many 10 20 inputs are there, right? It will be running on those inputs. So submit also passed, so this code passed. So this editor is very basic, because it works like a text editor which mimics the interview conditions. So you can test in work in here and then practice. So guys, if you like, then visit quickcode.com for more of the problems. Thank you. Bye.